Hello, everyone. This is Alfredo Abate, your current Chicago Oracle Users Group president. Welcome to today's webinar. As an attendee, you'll be in listen-only mode. You can ask questions in the chat window, which we will monitor. All questions will be answered at the end of the presentation. We'll also be streaming live on our YouTube channel, and the recording will be available to view shortly after the presentation's finished. It's great to be here with you today virtually. For those that are new to the Chicago Oracle Users Group, we welcome you. Traditionally, our group meets between 4 to 6 times per year in various locations around the Chicagoland suburbs for presentations, as well as hands-on workshops by Oracle experts, ACEs, and authors. Of course, with the restrictions in place due to COVID, we decided to go virtual to continue to deliver awesome technical content to our members. Today is our 20th and final webinar of our series of 20, and I really cannot believe how quickly 20 weeks have gone by. You can visit our website to view the past webinar recordings and download the presentations. And our website is in front of you. You should see that it's COUG.us. Our user group runs completely unfunded. Our members don't pay any dues, and our meetings have always been free. I'd like to take a moment to thank our sponsor, OAPS Net Partners, for providing the Zoom webinar platform. They are an Oracle Gold partner and systems integrator with specialties in areas of financial business solutions based on Oracle applications, both on premises and in the cloud. They provide services in the areas of AP automation, Apex development, database upgrades, and administration. And today, we are honored to have Oracle PL/SQL legend and former Chicago native, Mr. Stephen Feuerstein, on newer features of Oracle PL/SQL. Hi, Stephen.
Hey there.
I'm going to stop sharing my screen and give you control.
Do I have control?
You should be able to share.
I'm in control. Cool.
You're in control.
Hey, everybody. So let's share my screen, get the show on the road. Well, good to see you all sort of virtually. It works well for me because I hate to travel and now travel even less than I was traveling before, but it's really nice to be with people as well. So hopefully in 2021, things will get better, life will be safe, and we'll sort of get back to some kind of normal. In the meantime, happy to be with you virtually. So, as Alfredo said in his great introduction, my name is Stephen Feuerstein. I'm a developer advocate at Oracle and lead a team of 2 other developer advocates, Chris Sachs and Connor McDonald of Ask Tom fame and more. And our job, briefly put, is to help developers and any users of Oracle database get the most out of their investment in that incredible technology. Hopefully you have no trouble finding me online. I've got a Twitter account, I've got YouTube, I've got blogs, you name it, just search it and you'll find it. And what I'd like to talk about today are some of the newer stuff, the newer features that we've been adding into PL/SQL. Before I do that, though, I'd like to just mention to make sure that you know about 3 key websites with a lot of information and resources for database developers. Obviously, those are not the only ones, including the great website Oracle Base, oracle-base.com from Tim Hall. But these are 3 websites from Oracle, from Mike Hitchwa's organization, I work for Mike, that are really community-centered and community-based. So Oracle Ask Tom, Oracle DevGem, and Oracle Live SQL. Oracle Ask Tom, I'm sure you're familiar with. I can't imagine you wouldn't be. It's been around for, well, hopefully, I think 20 years and a few more years. And it is one of the best places to go still, even in the age of Stack Overflow, one of the best places to go to get your questions about Oracle database answered and get really definitive answers. So that I think that part of Ask Tom is well known. 2 years ago, in 2018, we added a new program called Office Hours, in which you offer dozens of sessions each month from database experts inside Oracle and sometimes external speakers as well on all aspects of Oracle database technology. You can subscribe for reminders, just check in and check out a session. You can check out over 600 videos in our library of past sessions, an enormous amount of information available on all aspects of Oracle database technology. So that's Ask Tom. The DevGem is a website where you can take quizzes, workouts, and classes as kind of active learning environment. So it's great to read books. It's great for some people to watch videos. I can watch videos online. Never can do it, but I know it's really big with a lot of other people. But that's fairly passive. You read it, you absorb some of it, but when you get right down to it, you have to use the technology to really get into it. And the most important way to do that is to write code. What we offer the complement on this website of actually engaging through quizzes to test and verify and deepen your knowledge. So check out all the resources at these two sites. And finally, and we'll be using this one a fair amount today, Live SQL. So Live SQL gives you the ability to play around with Oracle database. Gives you access to the latest version of Oracle. We're on 19C currently on Live SQL. And you can write SQL, you can write PL SQL to your heart's content. We also offer a very large code library of code snippets and tutorials, and we'll be actually looking at a bunch of those during my talk today. Okay, so nice resources, take advantage of them, all free, 100% free, they'll always be free. In terms of this presentation, you can go to slideshare.net and just look for PL SQL new stuff, and you'll find at least a slightly earlier variation on this presentation. You can also get all the code by downloading this zip file, bit.ly SF demo files, and you'll have a couple of thousand of scripts that I've written over the years, including those files referenced inside the PowerPoint. Or, and you'll see reference to this in the presentation as well, go to livesql.oracle.com and search out the same set of scripts as well. But there you can immediately run them and try them out. So hopefully all of that will be of use to you. So a roundup of some of the newer PL SQL features, and I'm going to be cutting across features that have been added, well, originally in some cases, even in 11G, though really taking hold in 12C and then beyond into 18C. 19C did not have much for PL SQL. 21C, which we'll be releasing very soon, notice we kind of skipped over 20C, has some really cool stuff, and I'll mention that at the very end of the presentation. Now, I could talk about each of these different items here, but Connor McDonald insists that you should no longer have agenda slides like this. And I certainly agree we shouldn't read through them. We'll just cover the topics. But the bottom line is that, as even in a language like PL SQL, which is relatively stable, which doesn't change and evolve all that quickly, it's hard to keep up with the new stuff, and it's hard to integrate it and internalize it into your code. So it's nice to get a reminder of what's out there, and hopefully some of it will catch your attention and you'll say, I was working on that problem last week, and this could have really helped me. And then you can start to integrate these things into your day-to-day programming. Let's dive in. So first of all, qualified expressions. It's a fancy kind of obscure name for what I think most people would call a constructor. So object types, nested tables, and V-arrays have always had constructors since they were first released in Oracle 8. And a constructor is a function with the same name as the type that essentially initializes and returns an instance of that type. It could be a new nested table, a new V-array, or a new object type instance. But our own user-defined types like associative arrays and records didn't have that capability. Well, in 18C, we added that capability, and for some reason, we called them qualified expressions. So very briefly, in the old school way of writing code, I might declare my associative array, and I know it's an associative array because it says index by. It used to be called an index by table. This is the oldest and most commonly used form of the collections in PL SQL. But if I wanted to populate my array, I would essentially have to do it line by line with explicit assignments, which is quite cumbersome, especially if you want to get it done in the declaration section. So now with 18C, I can call a function that looks like a function of the same name as the type, and then I can pass it the elements right in line inside parentheses. So let's go over to Live SQL. For our first visit, search out qualified. And then I find a number of hits. And again, I encourage you, if you haven't done this already, go to Live SQL, do some searching around. You can search for things like 18C and find all the new scripts for 18C, and you'll just find tremendous amounts of content here. I've got, I believe, about 240 scripts just on PL SQL topics alone. So let's start out with qualified expressions for associative arrays. So if you want, you can open up the script, and you'll see that I've already run it, so it shows you the results, but you can also run it yourself. That will put all these statements into your session, and then you can play around and make changes and kind of learn more about it. So here's the old style of doing things. There's my array declaration. the new type, a variable based on that type, and then line by line assignments. Ugh. Okay, now I can write code like this. So I call that qualified expression of the same name as the type, and I assign it values. And notice you have to use named association. So if you try this, it doesn't say, oh, you want to put it in the first and the second and the third locations, because with associative arrays, any expression or any index value from -2 to the 31st plus 1 to 2 to the 31st minus 1 are valid array index values. We don't just start at 1 as we would with a nested table. So you have to specify the index value with the old name notation association, and then you're good. Then it has the same effect. And so notice again, you can do it right inside the declaration section, right in line. Now, of course, as a quick reminder, I'm sure a lot of you know, one downside of doing this kind of coding in the declaration section is that if for some reason the initialization with your qualified expression raises an exception, then this block will not be able to handle it. Even if you have an exception when others will propagate all the way out. Chances are, though, you're not going to be raising an exception in this part of your code unless it gets pretty complicated. All right, let's explore further. Notice, of course, you don't have to put them in any specific order. That's the whole point of the name notation usage. You can even have positives and negatives, etc. They can be not sequentially filled in any order you want or any values you want. Let's see what else we've got here. And here's an example of working with records. So I have a separate script for this, but we'll cover it right here. I declare my record species, record type, give it the different fields. Then I declare a collection based on that type. So I've got a collection of records. And then right inside my declaration of my array or my initialization of my array, I call the array qualified expression. And then to assign values in the array, I call the qualified expression for the record type. So right in line, I'm creating records of those types. And notice in this case, I don't have to use name notation. It'll just put them in the order in which the fields are defined inside the record. So nice, concise coding, less work in terms of writing all that code out in your executable section, and again, being able to do it inline in the declaration section. Nice enhancements. Let's see if there's anything else. Yes, and also you can do the same thing for string indexed arrays. So historically, we'd often come out with new features for associative arrays that are integer indexed only. But this works for string indexed arrays as well. And again, you can see why name notation would be critical here. There's no sense of an order, really. Well, there's an order alphabetically, but there's no sense of sequentially defining elements in an array. There goes my dog. No longer on my lap, I'm free. Okay, so then I can just simply assign values to that location, to the Stephen location, to the names of my granddaughter's locations, and all the code works just fine. You can even use expressions when you're doing those, when you're determining what the index values would be. They don't have to be literal values. So very flexible, very powerful, and a great way to essentially reduce the amount of code you have to write. Really nice enhancement. All right, let's move on to PL scope. So this is an example of a feature that was added originally in 11G. It was powerful then, but it got tremendously more powerful in 12.2. And if you've ever tried to do dependency analysis in PL SQL or the database, historically what you would do is rely on views like user dependencies or all dependencies. And that's great. I can answer questions like which packages or which database objects generally rely on or reference a given table. And that's very nice. The problem is that it's not very detailed. So if I want to know, which of my packages do inserts into table X? Can't do it with user dependencies. You can't even say which of my packages reference a specific column inside a table. We actually do that kind of fine-grained dependency analysis. We started doing it in 11G release 2, but we've never made it available in our user views. Apologies, mea culpa. Fortunately, we give you PL scope instead, and it's way more powerful, way more interesting, and the questions you can answer are sometimes, I think, just mind-boggling and exciting. So for example, I can ask, where is a variable assigned a value in a program? So what I could do is open up my file of text and search for a given variable name, and I can just see every place where it's referenced. But I ran my code, and somehow it's being assigned a null value, and I don't know why. So with PL scope, I can actually ask, where are all the different places in which this variable could be modified in some way? So it could be a select into, it could be a direct assignment, it could be an out parameter, all sorts of possibilities. And PL scope will be able to answer that kind of question. Come here. Here comes my other dog. All right, it's a black dog, so you can't see her, but she's here. You can do much more fine-grained dependency analysis, so you can actually find out which subprograms are called in a package are called from other packages, not just the dependency at the object level. And many, many more things like that. So for example, you can do full CRUD analysis now. You could ask, find all the procedures that do inserts into this table, all the package procedures and functions that do a select against. And the most exciting thing for me is that as of 12.2, we started analyzing information about the SQL statements inside your PL SQL code. So prior to 12.2, PL scope only analyzed the code, the PL SQL code, not the SQL. So let's go ahead and take a look at some of the things PL scope can do for you. So I will simply search for PL scope. And you'll see that there are lots of examples here. And I also have a blog post called the PL Scope Resource Center that has lots of links besides things here. So let's just take a look at some of the kind of things you can do without going into too much detail. There could be a whole presentation just on PL Scope. So to turn on PL Scope, and by default it's turned off, you alter your session, or you could even say alter procedure or alter package. You can get down to that level of granularity. And then you set PL Scope settings. Prior to 12.2, this was the only option, identifiers all or identifiers none. And this would analyze your PL SQL identifiers. As of 12.2, you can also say statements all, and that will pick up the SQL statements. But this one was created actually before 12.2. So then I create some code. We won't, again, go into all the details. Here's just some quick examples of some queries. So here's the user identifiers view. And I simply want to get all the identifiers for a given object. So for the PL scope demo, package body, and I'm going to create, using my with clause, I create my little PL scope hierarchy, and then I do a select from that hierarchy view, inline view, and then I can see things like, well, you don't see the indentation because Live SQL gets rid of the indentation, unfortunately, but this will basically show you that within my PL scope demo, I have a procedure. My procedure has a formal parameter. Its type is integer. The second parameter is a collection based on the table. Let's see, is that right? I lost track. Yeah, table percent type. So you get all this detailed information, including down to individual variables and so on in that package. All right, let's take a look at something else. You can even, with PL scope, use it to validate your naming conventions. So if you have a rule for your naming conventions that you can express in SQL, you can implement them in PL scope. So for example, for me, my definitions or my standards for parameters is that I use underscore in for in, underscore out for out, and underscore IO or sometimes in out for my out parameters. So this is a piece of code that looks for all the parameters. So the type of my identifier is a formal in or in out or out. Those are the formal parameters. Look at the declose parameters and then check the name and make sure that they match the pattern. So this is a very simple example, but essentially you should be able to, let's put it this way, if you can't express your standards for naming conventions in a SQL statement, there's probably something really wrong with your naming standards. And assuming you can, then there you go. You can get what you need to get at. No, you can't put your muzzle on my keyboard. Then you can code it inside PL scope. Let's see, what else we have here? Here's a good one. Find usages of the variable declared with a given name. So this finds all the ways that this variable, so I get its declaration, and find all its references inside this body that are not declarations. And here's that assignment to the variable. All right, let's look at a couple of other things. Again, don't want to spend the whole time on this, but here's my favorite one actually. Find duplicate SQL statements in PL SQL. Now, it's not uncommon. So one of the great things about PL SQL is that it's so easy to write SQL statements inside it. You just write native SQL, no need for JDBC, string concatenation, etc., unless you're doing dynamic SQL. And then you want to avoid concatenation anyway. So I just write my static SQL directly in PL SQL, and that's wonderful. The problem is that it makes it too easy to write SQL. And generally speaking, a lot of organizations, even if they have all these standards about how to write PL SQL, Don't put any rules in place for SQL. You just go do whatever you want. And you can create a real mess. And one of the kinds of messes you can end up with are multiple instances of the same SQL statement appearing throughout your code. And it's really hard to tell that they're the same unless you literally copy, paste, and they look exactly the same. And then somebody could format the code differently anyway. So for example, here's P1 and P2. These SQL statements look really different, but in fact, they're the same statement. Logically, they're the same, and even in a sense, physically the same. Now, they look physically different. And if you know a lot about Oracle database optimization, you probably know that when two SQL statements are the same, but they're physically different, then they will both be parsed by the database. In other words, the database, one of its optimizations is it does a quick hash of your SQL string to a number. And if it finds a match for that number in its cache, it says, oh, I've already got one of these. And if there's the slightest physical difference, capital S versus lowercase s, and extra space, they're physically different and it gets hard parse, which is a problem. Here's the great news about that situation. If you put your SQL statements inside PL SQL, then when this code is compiled, this statement is canonicalized, basically standardized in format, all the extra white space removed, all the keywords uppercased, et cetera, so that in the end, after compilation, this statement and this statement are actually exactly the same. And I can show that to you right here. So after I compile those programs or run them, I can select from user statements. And notice I've got two different SQL ID, I've got two different signatures, sorry. This is in PL scope, so let me go back a sec. Notice now I've turned all statement analysis on. So when it compiled these programs, it gathered information about these SQL statements. And here it is. I've got two different signatures. There's a unique signature for every place any particular element occurs. But notice the SQL ID is exactly the same. This is what the SQL statement looks like post-canonicalization. And you can see they're exactly the same. Even the fact that one of them said ID in versus a different named parameter, they're both parameters. But even if it was a local variable, it would still look like that, :B1. So I might have multiple iterations of the same SQL statement formatted differently. How do I find the duplications? How do I get rid of the duplications? Well, turn on PL scope. You can ask questions like this. Select from all the user statements where I've got a SQL ID, group by that SQL ID, having count greater than 1. And there they are. There's my instance of duplicates, the number of times it duplicated. And I can actually go and find where they occurred in my program. So I think that's one very simple example of the power of PL scope and what you can do with it. And there's so much more you can do with it. Again, we could probably spend the whole time just on PL scope in this session. I encourage you to check out a lot more of the information here. Check out my PL scope Resource Center blog post. And that'll also link you to some really amazing utilities written by Philippe Salvesberg that will integrate into SQL Developer as well to help you use PL scope there. Okay. Back to PowerPoint. All right, another feature added back in 12.1 is the accessible by clause. And this is a feature that basically helps you control access to your code. Now, of course, we already have the basic control of granting execute on a database object so people can see it and use it from outside of the scheme in which it's defined. But this gives you an additional level of control. And to me, the basic idea or the biggest use case here is that when I've been writing code for a long time, then over time, a package that might have been 100 lines long or a couple 100 lines long can get a lot longer. For example, the devgem, of which I have written the backend, the PL SQL backend, probably has about 50,000 lines of code. I actually just reduced it by about 15,000 by cleaning out old code about a month ago. That was an exciting time. But it's still a very large amount of code. And sometimes my packages, individual packages, grow tremendously larger than they were originally. Now, that's not a big deal in general. I mean, having a 10,000, 15,000 line package is not a problem for PL SQL, assuming you don't run out of the number of Diana elements and your package can get too large, just very unlikely to happen. But it can be hard to manage. It can take a little while to compile. It's difficult to have multiple developers trying to work on the same massive package body. You can't do it at the same time. So you might over time say to yourselves, well, this is one big package, and over time it's actually grown in scope, so it's doing several different things. And what I really like to do is break it up into multiple packages, but all I want to do is break up the package body. I don't want to break up the package spec. That can stay the same. So I want to have multiple, essentially I want to have multiple private package bodies for a single package spec. A curious idea, right? You can implement that with the accessible by clause. And the basic idea is that in my package body for my public package, the one that anybody sees, inside the package, the package body for that package spec, which used to be, say, 15,000 lines long, now all it does is redirect to some private package. Now, it's not really a private package. If I'm connected to that schema, I can still see and work with that package, edit it, and so forth. But by putting the accessible by clause on it, that means that it is private in terms of the ability to execute the code in that package. And what this is saying is that the only way that this code can be referenced is from the public package. So that's a nice little enhancement to help you organize and and control access to your code for other developers. There are still ways to work around it, but the main thing is you're kind of expressing rules about how you want this code to be used. And in 12.2, you can also narrow down the accessibility down to individual subprograms within the broader package. More PL/SQL-only data types across the PL/SQL-to-SQL interface. So prior to 12c, if I was doing dynamic SQL execute immediate, then the only types of data that I could reference inside that execute immediate string, whether it be a SQL statement or a PL/SQL block, were elements of SQL types. So for example, Booleans were out of usage. User-defined records and types could not be referenced directly inside execute immediate, even if they were dynamic PL/SQL blocks. And that's now something that's been eased up. So let's take a look at binding. Is that it? That doesn't seem right. Let's see. No, bind doesn't work. Let's see. I might switch to SQL Developer if I can't find them quick for you. One more try. Let's just look for 12c. I'll do a quick search here. Sorry, I obviously should have checked all of my elements beforehand. Okay. Huh. All right, here's your accessible by, so you can check that out. And we're going to go over to SQL Developer. All right, so let's take a look at binding Booleans. And by the way, if you look at in any of my code, if you see this COUG underscore or PLCH underscore, this is code that I've used in PL/SQL Challenge and now the DevGym quizzes. So notice that in my procedure and function, or my procedure, I'm passing in a Boolean and the function returns a Boolean. And as of 12.1, now I can actually say I can call that procedure and I can actually bind in Booleans natively. And I can call the function and return a Boolean value, and it knows what to do about it. So simple enough. So, and I think what you'll see with a lot of the newer features in 12.2 and in 18c, we're kind of smoothing out the rough edges. We're looking for things that we haven't quite gotten to and finishing them up. Same thing here. And what's really nice, I think the best part of this is binding, that's DBMS SQL, just I'll show you real quickly, but you can also do the same thing with DBMS SQL. So that's the older version of dynamic SQL. You can now bind Booleans as well, which you couldn't do before. But that's not what I wanted to show you. Bind collections. Now, in the old days, prior to 12c, one of the really cool things about nested tables and V-arrays compared to associative arrays, so this is a nested table declared at the schema level. There's my constructor function that initializes it, et cetera, et cetera. But one of the really wonderful things about nested tables and V-arrays is I could use the table operator and I could convert that array into a format that looks like a relational table. And I can select from it. I can join it to other data sets. I can essentially merge in-session data, in-memory data that's not inside any table in the database with data in my tables and then do whatever I needed to do with them. But this didn't work for associative arrays. As of 12c, that is no longer an issue. So I've got my collection declared at the package specification level. The SQL engine still needs to know about it if you're going to reference it inside SQL. But now I can call it, for example, right here, I'm calling the display names procedure. I'm getting back my array, or I've got the same array. And then I can also select from table. So I can bind in dynamic SQL. And I can also select from it as if it were a relational table construct. Really nice. Again, if you've been doing with nested tables, you already know about it. You won't be wowed by the fact you can do it, but hopefully you're excited about the fact that now you can do it across any of the different kinds of collections. And the same thing with your user-defined record types. All right, let's talk about optimizing function execution in SQL. Let's go over to here first. Let's see if I have anything with switch to show you. Yeah, this is a good one. Okay, so take a look at my select statement. I'm selecting and I'm calling a function. So one of the really cool things about Oracle SQL, and I'm sure other databases can do it as well, is that I can declare PL SQL functions that I can essentially extend the SQL language with. So inside my select statement, or the where clause of an update statement, etc., I can actually call a function. And what you see here, in fact, is this function then executes a select statement of its own and then returns some data. And it calls another function inside that select statement to construct the full name. Now, every time when I execute this select statement, it's got 107 rows in it. Every time it calls this function, we have to switch. It's called the context switch from the SQL engine to the PL SQL engine or vice versa. And those context switches are relatively expensive, which is why Oracle introduced bulk processing way back in Oracle 10, was it earlier? That allows you to avoid or reduce the number of context switches. And we're going to talk about how we can reduce context switches even further with some features in 12c and above. But first, I just want to talk about what's going on here and the dangers of it. So first of all, I switch here from SQL to PL SQL. Then I switch from PL SQL to SQL. Then I switch from SQL to PL SQL. So multiple context switches layered in, which is a terrible, terrible idea. Hopefully you never write code like this. And it's not only terrible because you get a lot of context switches, but it's also terrible from the standpoint of some serious data consistency issues. As I'm sure you know, when you write a SQL or when you execute a SQL statement like this, let's say it takes an hour to run. In fact, let's say it's a for loop. For record in, do all this, loop, do stuff, and loop. So this thing runs for an hour. And while this thing is running, let's just say employee ID, not emp name. So it's just SQL. Runs for an hour. And while this thing is running, somebody else comes along and deletes everything from the employees table and commits. Will that affect this program running? Not at all, unless it goes for too long and then you might get a snapshot too old error. But assuming you don't get snapshot too old, it'll give you a read consistent image from the time you started executing the query. That's really great. But now let's suppose my code looked like this. Inside my select statement, I call a function. Inside this function, I execute a select statement. This select statement, any SQL statements inside your functions are not part of the read consistent image of that outer query. So inside this function, I select from employees. And when I'm 45 minutes through my hour and the entire table has been deleted and has no rows, this will start to return no data found. It's actually really silly. There's not even a where clause there, so it would have returned too many rows already. But anyway, the point being that when you're calling your own functions inside SQL, they really should never have SQL inside them, if only for context switches, but more importantly, because of the read consistency. So if you do have functions that have SQL in them, just please make completely sure that you're not creating that kind of problem around data consistency. Okay, so that's the brief talk about context switches moving between SQL and PL SQL. So let's say you've got a function that is mostly or almost always going to be called inside SQL. What you'd like to be able to do is reduce the cost of that switch between SQL and PL SQL. And there are two methods now for doing that. One is using a with function clause, and the other is using the UDF pragma. Let's see, table function with, is that what I wanted? That's not what I wanted. Here we go. So here's how it looks. Here's my select statement. And as I'm sure you know, you can have common table expressions. You could say with select or with, I think it's, what is it? My name as select. And then I can reference this in my SQL statement. I can actually even join, let's say, to employees, things like that. I'm sure hopefully you're all familiar with that. So that's been around for a very long time. Now you can also declare procedures and functions. So in my code, I declare a procedure. In my function, I call that procedure. And in my select statement, I can call the function. You can't call the procedure directly inside your SQL statement because it doesn't execute, SQL doesn't execute code, but you can call a function return values. And the advantage of using the with clause here is that it cuts down on the cost of the context switch. It doesn't remove it entirely. You still will have a switch because the PL SQL engine has to process this code, but it is at least reduced. Now, the use case for this, I think, is pretty narrow. If you have a common kind of silly little expression like concatenating first and last in 6 different places, doing some relatively small deterministic calculation, you can put it in your function, and then it's referenced, defined once, and referenced multiple times. That's the best use case for this. I would not put any elaborate business logic in your with function clause. Put it inside your package. Yes, you've got the context switch, but you should be able to manage that. And in fact, the other feature I'm going to show you would help you do that. But the other use case is if you're working on a read-only database, let's say an archive database, and you're not allowed to create database objects in it like a function, here's a way that you can actually write queries that have more complex logic in them, PL SQL logic in them, and then you can still create them and execute them. Now I'm going to put my puppy down. You're getting too restless, Moonbeam. Okay. All right. Now the other thing you can do in terms of reducing context switch cost is the UDF pragma. Here's my function called UDF function. Let's get rid of that stuff for a moment. I'll come back and just reference it in a little bit. But here's the basic idea. You can add pragma UDF to your function. Now what this tells the compiler, and a pragma is always a compile time directive. There's no runtime overhead of having a pragma in here. What this says is, hey, I'm going to be using this pretty much all the time inside. What is that? Go away. Leave. What are you doing? Thank you. Sorry about that. So what I'm saying is pretty much all the time, I'm going to be calling this from SQL. And that means that at the time this code compiles, when the PL SQL code compiles, the PL SQL engine will do some of the things at compile time that it normally would wait to do at runtime. So again, the cost of the runtime switch is reduced and pushed into the compilation process. And currently, you can get mixed results for the UDF pragma. You can search online for lots of examples of this. It optimizes number. I don't think it optimizes for varchar 2 parameter types. So you might not see all that much of an advantage from it, except in more specialized circumstances. But again, the main idea is that if you know that your function is most likely almost always called inside SQL, add the pragma. At most, it won't do any harm. It might not do any good for you now, but in the next release of Oracle, as we make it more and more sophisticated, cover more and more of the possibilities, then you'll see your application being able to get faster and faster. So, and in general, I think this is good advice. If you can declaratively tell the compiler about your code, then you should take every opportunity to do so. For example, I should also declare this to be deterministic. Deterministic means that whatever value I pass in here completely determines what is returned. And actually, this isn't quite true because we have format mask issues, but here, implicit conversion issues. Let's change it to this, n times n. So this is clearly a deterministic function. If this changes, but if anything else in the database changes besides going down, it doesn't affect the behavior of this function, what it returns. That's a deterministic function. Now, I have to declare functions to be deterministic if I want to use them in function-based indexes. I also can get some advantages in performance by doing some caching if it's a deterministic function when it's called inside a select statement. The caching is probably of relatively minimal use, but still useful. But the main thing is you're giving the compiler more information when you say it's deterministic. And it can take advantage of that in a variety of ways. So do it and don't lie. If it's not deterministic, don't declare it to be deterministic. Trying to fool the compiler is never a winning strategy. But you can take either of these approaches, either the with clause for your function or the UDF pragma, and reduce the cost of that runtime context switch. Okay, time to cruise right along. util call stack package. So back in Oracle 10G, we added some really useful functions: format call stack, format error stack, format error backtrace. Actually, the first two were added before 10. Format error backtrace, the best of them all, was introduced in 10.2. And they answer questions like, how did I get here? A called B called C called Q. Or what's the error message in stack? Basically, this is a replacement for SQL error message function. Format error backtrace traces back to the line at which the error was raised. Really cool stuff. And in general, these functions should be used in your low-level generic tracing routines or error logging routines. So in general, developers shouldn't be writing this stuff over and over again. It should be deposited inside a low-level routine that everybody calls. So they're good stuff, but maybe not as flexible as we'd like. For example, the reason they're called format underscore is that they return a formatted string. And you get that string and you have to figure out what to do with it. Now, what I have historically done with these strings is not try to parse them, though I've written some parsers for them. I just put them out into my log table or my error table, and then I look at them later. But we added util call stack. Let's go back over to live SQL, util call stack. And this is a package, a utility I wrote to actually emulate in util call stack all the functions you're probably already using. And the basic idea is that with util call stack, you get access to the individual elements in the stack. So before it was a string that was just passed back to you and you could see the stack or the trace. With util call stack, you can actually iterate through the elements in the stack. You can display them, you can do whatever you want. And that's the primary advantage of util call stack. There's also an ability to get information that takes you all the way down to the nested subprogram in which an error occurred, which previously wasn't available with format call stack and format error stack. But those are also being improved over time and adding more and more code. So the bottom line is that you should check out the live SQL scripts. If you want to do some really cool, unusually detailed stuff with those stacks and traces, call stack will let you do it. But in general, my impression is that you're probably not going to be using them very often. Okay, continuing on in the area of like little things that can make a big difference if you happen to hit this kind of issue, if you're kind of obsessive about how you write your code. You can now use static expressions in the place of literals. For example, historically, if I want to declare something to be the biggest string possible right now, I would declare it as varchar2 32767. Some people might even argue, hey, you should always declare every variable. I actually have people who have been pushing for this. Every variable in your code should be declared as varchar2 32767. Now, I think that's a terrible idea because it looks weird and it just makes people ask questions. It won't end up using a lot of extra memory because we optimize and only allocate memory as needed. But it's really a drag to hard code it. Among other things, what if in the future we raise it to 64K? What if in the future there's no difference between varchar2 and CLOBS? Hard coding that limit is always a drag, but you had no choice. It had to be a literal. Now you can actually use static expressions. They could reference constants. This is actually a predefined constant, Oracle max name length. Or you can have expressions as long as they can be completely evaluated at compile time. That's what static expression means. So now you can avoid that kind of hard coding and give you a little bit more flexibility. I'm sure this is old news to all of you. If not, well, let me be the bearer of good news. For years and years and years, Oracle database is kind of like the old MS-DOS, which remember file names? Well, remember, for those of you my age, file names with a maximum number of 8 characters. So inside Oracle, historically, you had a maximum of 30 characters for your names of database objects. And in general, it's good enough, but sometimes we get right up against it and it's a pain. And of course, if you come from some of the languages that allow much larger names, it can not only be cumbersome for you to make the adjustment, but if you want to do a migration of your code into Oracle, it presented some serious issues. So now you can go all the way up to 128 bytes in your names. They can get really, really long. I really hope that you'll never create identifiers that have names that go up to 128 characters. The way I've used it mostly is I no longer, when I'm getting close to 30, I no longer have to stop and say, what do I cut? How do I make this less readable? But I can go to 32, 35 and lay it all out in clear English or whatever my language is and not have to make the compromise. So a really nice little enhancement. And by the way, I'm sure you've experienced this yourself, but this is something we've been asking for years. I say because I was away from Oracle in 2014. People have been asking for it for years. And I'm sure from the outside, you look it up and you say, well, why don't you just change the 30 to 128? What's the problem here? Well, the problem is that it sounds like it's easy on the outside, but on the inside, there was a lot of code to change. Data dictionary views, lots of low-level code, but we finally knuckled down and did it, and now you've got the benefit. Goodbye, tiny SQL varchar 2. So another irritation historically is that the maximum size of a string inside SQL was varchar 2 4000. The maximum in PL SQL, 32,767. And now if you set your max string size initialization parameter of the database to extended, then you can declare varchar 2 columns in a table up to 32,767. Now that's something the DBA needs to do, and it's a one-way trip. Once you've made that change, you can't go back to non-extended. Not sure why you would, but it's not something that by default is available to you. The DBA has to take that step. Kill off old, dead, should be zombie code. But how do you know where it is? So if you're like me, you have code that has lasted for years and years and years. And one of the things that happens for sure is that over time, some code is not being used anymore, or at least you want to make sure it's not used in the future. You want to deprecate it with the objective that at some point later, you would remove it. Well, now in 12.2, you can actually document deprecated code. Let's take a look. So what I can do now is put in a pragma that says this entire package is deprecated, or I should have an example down here. I can document individual procedures. Where is that? There we go. I can also document individual procedures within a package as deprecated, and I can also provide a message. So how is this useful? First of all, I can declare things to be deprecated. It doesn't make any difference in terms of the code compiling and running. You can run deprecated code. But what I can also do is turn on compilation warnings. So I can set PL SQL warnings on. I can enable all or a subset. I won't get into those details right now. And then when I compile the code, I'll get feedback. I'll get warnings saying, hey, that element is deprecated. And here's a reference to a deprecated entity. So this is just repeating what you already know. I've got the pragma there. But here is an attempt to use a deprecated program, and it tells me that it's deprecated. And if I provide a message, then it'll actually include that message. So I can say, hey, this is deprecated. Here's what you should use instead. And then at some point, if you say to yourself, I don't want this thing to be used anymore at all, you can also inside your compilation warnings subsystem, you can specify certain warning codes to be errors, not warnings. So this is a warning. See the PLW? That's a warning. This is an error, PLS. So when you take this step, this will actually stop your programs from compiling if they have deprecated elements in them. And you don't have to set it at the session level. You can set it for individual program units, which allows you to basically say, for these program units, I don't want deprecated code to be in them anymore. Get them out. We don't let you select which of your deprecated code you want to say is no longer acceptable. This is just at the overall warning level. But at a minimum, it does give you the opportunity to document the deprecated code, which I think is probably what we'll mostly do, and not actually use the warning system to turn them into errors. But at least then you can go and find all the code that's been documented as deprecated when the time comes to do the removal. I'm going to finish up with a few different privilege-related features and give you a glimpse of 21C, and then I'll be out of time. Wow. Okay, so to move through this fairly quickly, we're not going to get into the coding details because conceptually it's important to know about, and then getting into the weeds, there are a lot of weeds. As of 12.1, you can now grant roles to program units. So that in previous instances of the database versions, I could grant a role to a schema. And then that schema inherits everything, all the roles, all the privileges in the role are adopted for the user. Now I can associate a number of privileges with a role and associate the role to a program unit. So much more granular fine tuning of privileges. If you're doing a smart DB, if you're building comprehensive APIs around your data structures and even your program elements for application developers to use, then this kind of flexibility allows you to do very, very tight control over who can do what. Bequeath current user was added in 12.1, and essentially that allows you to do the full invoker rights implementation even through views. I'm not going to go into more detail now because I am running out of time. I'd be happy to take that in questions, but you can take a look at the script in my demo, or you can go to Live SQL and search for, you guessed it, bequeath. Let's verify it since I couldn't find my binding ones. In fact, let me write a note to that to fix that. Okay, code library, thank you. Bequeath. Huh, all right, I'll have to look into that too. But now I have to show you here. So just very briefly, when you're declaring a view, you can say bequeath current user, and then it acts like an invoker rights or current user program would work. Happy to look at that in more detail in the Q&A. Think finally in terms of settings for privileges. There's a new privilege added in 12C called inherit privileges or inherit any privileges. And this allows you to override individual auth ID and bequeath settings. Essentially, you can revoke inherit privileges. And then if you're using an auth ID environment, a current user in which you're invoking the privileges through other schemas, it will not allow you to do that. All right, final topic. Let's take a quick look at one of the really nice features added in 21C, and that is new iterator controls. So the PL SQL team went crazy for 21C in terms of iterators. And I think the basic way to think about it is that we've caught up with other programming languages which have had much more flexibility around loops and iterators. And then we've also gone a step further, as we usually do, by adding in functionality specific to the database. The first one is my favorite for sure. So let's first of all take a look at the old tough way of doing these things. I'm going to go back to my associative array example. So I've declared my associative array. It can be sparse, which means there are gaps between the lowest and highest defined values. And here they are. Wow, that is a very sparse array. I start from minus 15,070 and go up to that big number. And only a few elements are defined between them. And historically, what that has meant is that if I want to iterate through that collection, I have to say, get me the first defined index value. While that's not null, do whatever I'm going to do, go to the next value from this one. And it kind of hops over any gaps in the array. Not a big deal, I guess, but oh, that's a lot of code to write. And why aren't you smarter, PL SQL? Well, 21 PL SQL, 21C PL SQL is smarter. Now you can use the same syntax that was first introduced in for all, and I can say for iterator in or for index variable in indices of the collection. Boom, that's it. It just automatically skips over them. So that I think is going to be one of the most favorite elements for anybody with a lot of PL SQL experience with collections moving into 21C. But it goes well beyond that, and I've only scratched the surface myself. You can now do very complex specifications within your for loops. So this says basically starting at 1 and go by 2s until you get to 100, and it basically will create step increments. And you can have like multiple of these different iterator controls embedded in the same for loop, doing wildly different things. I don't know how much you're going to use it or how much core there will be to do it, but it will all be there for you. You can even combine this feature inside things like qualified expressions. So here I'm declaring my collection. Here's my qualified expression function name. And then inside that, instead of saying 1 is assigned the value of 17 and 2 is assigned the value of 245, I can actually have a little for loop essentially inside there for I in 1 to 10, assign it to that location I. So this will automatically set it up with 1, 2, 3, 4, up to 10. So tremendous amounts of power and flexibility here. You'll be seeing a lot more about that, obviously, as 21C rolls out and we start to publish blog posts and so forth on it. All right, it's 1:58, my time. So to finish up real quickly, what you'll see with the newer features of PL SQL is that the core functionality is there. It's been there for a long time, and it's never going to change. PL SQL does what it does very, very well, which is a database programming language. But we've had rough edges. We've had areas where you spend time writing code where you shouldn't have to write code, reducing your productivity, increasing your code volume, making it harder to maintain the code base. And we're working pretty much in every version now to cut it down, make the language smarter, make it more intuitive, make it more flexible so that you can write your code faster and easier, especially with collections and with less code. And then the other big emphasis, though I barely touched on it here, is much more management around controlling access to code with security and privilege management, whether it's bequeath, inherit privileges, CBAC, code-based access control via roles, and so on. So lots of good stuff. I hope you're able to take advantage of all of that, or at least some of that. And now, let's see if we've got questions. I don't see much in the chat window. So if you have other questions, now's the time to ask.
One question, Stephen.
Mm-hmm.
It says, has the length of your table names been extended beyond 30 bytes?
So Robert, I'm not sure if you're asking me about my tables in my application, but so first of all, you don't have to do anything in your database to make that available. For example, if you want to change your maximum varchar2 size from 4,000 to 32K, that's something the DBA has to actually explicitly specify in the initialization parameter. The extension of identifier lengths from 30 to 128, that's just available to everybody as soon as you upgrade into 12C. Have I taken advantage? So I'll take that question. I mean, have I taken advantage of that feature? So for me, yes, the main path that I followed to take advantage of the feature is I no longer have to figure out how to cut off the size of my name and make a compromise in the words in the name of the table or package or procedure. I can now more naturally just let it work itself out, whether it gets to 32 or 35 or 40. The other place that I found this to be really useful is in code generation. So if I'm generating a package based on the table, I would usually put something like $PKG$ and then the name of the table. Well, if the table's 30 characters long, I can't put 4 characters in front of it, so I have to cut that and blah, you know. So no longer have to worry about any of that. Just go ahead and, you know, do whatever I want to do with the generation. And so it's made that certainly simpler as well. Hopefully that answered your question. Other questions? Quiet group.
I have a question.
Yeah.
Okay, so as we've been, told by Oracle, is that for long-term release to stick with 19C.
Mm-hmm.
So in the case of the new feature that's available in 21C with the iterators, is that stuff going to be backported to 19C via some patch? Do you know?
I can't say that I know for sure, but I can give you a pretty good prediction. These things will not be backported. I think the level of complexity of some of these features is pretty intense, and I don't think they'll do that. It probably, for example, SQL macros that were introduced in 20C or Preview 20C were backported or made available in 19C in a limited fashion. And that was probably done partly out of perceived demand, but also that it was a separate enough kind of functionality that they could move in without a lot of entanglements. I don't think things like iterator controls, you could do that. Now, having said that, the main idea behind our long-term releases and our innovation releases, so those are the intervening years. So I think it's every 3 years you get a long-term release, long-term support release. The idea is that in general, we don't historically upgrade our databases every time a new version comes out, right? The years would usually go by, and even when the new version comes out, people generally wait. And in terms of moving to production releases, it's a very slow and careful process. Now, hopefully the cloud is changing that to some extent. If you get onto a cloud account, we'll manage all that for you. But I think the way to look at it is 19C will be your stable production environment ongoing, unless you decide you need critical features and you install that innovation release and test them thoroughly and use them. The innovation release has basically become the next platform on which you're developing new code because you're aiming for that next stability release, or you're determining that the quality of the innovation release is sufficient for production. So that's the way we want people to think about them, is that's your stable production environment, but you want to get ahead of the game, and your developers will be looking at the new stuff and getting up to speed on them in the meantime. Hopefully that helps.
Yes, good answer.
Thanks.
I don't see any other questions in the chat. We'll give everybody about another 15 seconds. But in the meantime, I just want to say, Stephen, thank you so much for coming on today and giving us this great presentation of newer PL SQL features. It's always a joy and a privilege to have you speak to our group.
Thanks, Alfredo.
Chicago, you know.
I enjoyed my Chicago presentations. I would enjoy being back to present, except for the traveling part and so on and so forth. But
exactly.
Yeah, good to be able to see you folks virtually. And thanks for attending.
Yes, thank you, everyone. Well, the presentations, if you missed it at the beginning, I mentioned all the presentations from our 20 and 2020 series will be available for download on our site, as well as the link to the YouTube video. So you can go to those at any time. And as we've traditionally done with the Chicago group, we'll be taking a break for kind of the holiday winter period. And then we're going to see what we're going to come up with for 2021. Maybe another series of webinars. I don't know yet, but hopefully we can meet in person, at least in the latter half of the year. But we'll see.
Let's hope so. And let's work towards that. And let's stay masked and stay safe for all of our sakes. Thank you so much.
Absolutely. Thank you, Stephen.
All right. Take care. Happy holidays, everybody. Happy coding.
Yep. Have a good day.